All right, so welcome to our first graphing lesson. So this is 13.3, translations in the coordinate plane. Now, you should print out the classwork. There's a third folder now at the top of the page. So that worksheet that we normally have in class when we're graphing, I put it online. For those who don't have a printer, I have mailed it to you. Now, how did I know you didn't have a printer? I just didn't see any printouts in your pictures. If I seeing printouts in your pictures, I'm assuming you have a printer. I think that's pretty logical. So, here we go. So I want you to take this rectangle A and move it 5 spaces to the right. So how do you do that? You take the corners is the key, the vertices, 1, 2, 3, whoops, you're counting 5, 1, 2, 3, 4, 5 to the right. Then we'll move this corner 5 to the right. 1, 2, 3, 4, 5 to the right. We'll move this corner 5 to the right. 1, 2, 3, 4, 5 to the right, and so on. And we will move the whole object, rectangle A, and to the right. Now notice, when you move it 5 spaces to the right, there's not 5 spaces in between. Okay, and we label the new object with this little symbol, and that's called the prime symbol. And so the new object is called A prime. We've moved that 5 spaces to the right. So now take triangle B and move it 7 spaces up. Well, hopefully you went 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. Now you obviously can take shortcuts, right? Because it has to be congruent. The new object has to be congruent to the old object, has to be the same size and shape. So once you have 1 or 2 of the corners, you sort of know what the answer is, and we're going to label that with that flash mark. It's called B prime. So prime always shows you the new object, or also called the image. It says find the area of each object. Yeah, well, rectangle, right, is area of a rectangle is base times height. I'm going to say base times height instead of length times width. The base here is 2. The height here is 1, 2, 3, 4, 5. And so it is 2 times 5, or 10. Now, this is not 10 units. It's 10 square units, right? Because all areas are squared. Now, you didn't have to do it that way. You could have just counted that there are, in fact, right, 10 squares in there. 10 square units. Area of a triangle. This will B, triangle B, is 1/2 the base times the height. That's pretty sloppy. So 1/2, the base here is 1, 2, 3, 4. The base just means bottom. The height here is 1, 2, 3, straight up to the top. And we can do a little canceling, and this is 6 square units. You're going to be doing area problems and perimeter and know the difference for the rest of your math life. They'll just get more complicated and be in new situations. So there's 2 points there, and we started at A and we moved to A prime. The one with the prime is the image, the second part. So we know we started there. We don't know whether we went up first or over to the right first, but we moved this over to the right and then up. And what that's called is a translation. You actually did 2 translations of those objects in the warm-up. So when we move or slide an object in the coordinate plane, it's called a translation. So this is A to A prime that we did in the warm-up. So 1, 3 is now, so that arrow means is translated to, although it's used for other things, is translated to, right? Now it's 6, 3. Fill in the rest. 1, 8 has now been translated over to 6, 8. use a different color for this. 3, 3 has been translated to 8, 3. And 3, 8 has been translated to 8, 8. We're filling in the vertices, the corners. So fill in the coordinates of the vertices of B. So B, this is the one we did in the warm-up, right? So the one that was at -8, -6 is now up here at -8, +1. -6, -3 has now been translated to -6, +4. And last but not least, -4, -6 has been translated to -4, +1. So notice how one of the coordinates stays the same in each case when you do a translation in one direction. All right, so when we translate up and down, we add or subtract to or from the y coordinate. The y coordinate makes things go up and down. So we have line segment CD. It says move 3 spaces down and find the new coordinates. So again, you're just going to do the endpoints, right? It's not vertices now, but they're endpoints. All right, and then you're going to draw a new, we're going to label it C prime, D prime. And C, so you're going to label this C prime now, and C prime is, C was at -3, 1, C prime is at -3, -2. D prime, D was at 5, -2, now it's lower, it's at 5, -5. So let's look what happened there. We moved 3 spaces down. So we subtracted y by 3. X coordinate stayed the same. The y coordinate was -3 down. 1 minus 3, -2. -2 minus 3, -5. So if you went up 3, you would add 3 to the y coordinate. If you go down 7, you subtract 7 from the y coordinate to get the new one. All right, so try this. Translate point E, 5, 2, 7 units down. Now you could sit there and draw a sketch and go, all right, what's 7 units down? But there's a way faster way. Subtract 7 from 2, and you're going to be at 5, -5. And so we're going to say E prime is at 5, -5. Try this one. Pause the video. So point F moved from 3, -4 to F prime at 3, 5. So it went from -4 to +5. Well, what's that? What distance was that? Well, that was 9 units up, right? 5 minus -4 was 9. Let's just see that. So it was at 1, 2, 3, 1, 2, 3, 4. And then it went to 1, 2, 3, 4, 5, 6, no, 5, 3, 5. And so from 3 -4 to 3, 5 is 9 units up. All right, so if you add or subtract to the y coordinate for up and down, for left and right, you add or subtract to the x coordinate. Point G was translated 7 units right. Find the new coordinates. So we could add 7 there, but we're going to do it both ways. 1, 2, 3, 4, 5, 6, 7. There's G prime. So G prime, I better have ended up at 4, -8. Did I? 4, -8. Yes. Whoops. Now move this line segment 3 spaces to the left. Now you just do the end, you move the endpoints 3 spaces left, you move the whole line segment. So if we're going 3 spaces left, we're going to subtract 3 from the x coordinate. H prime should therefore be at -6, -3, -3 is not 0, it's -6, -6, 1. J prime is at 5 minus 3, 2, -2. And hopefully that's where we ended up. 2, -2, and -6, +1. We moved it 3 spaces left. All right, so move K 6 units left, or translate it as it should be called. 6 units left means you subtract 6 from the x coordinate. And so we should be at -1, 2 for K prime. Again, if you're not sure, yeah, you can sketch it. 6 units left. It's 5 to get to there, and then 1 more there. There's K prime, there's K. So from 3, -4 to 9, -4, we did what? Well, we went 6 units to the right because 3 plus 6 is 9, and we stayed at -4. Right, so typically when we do a translation, then you can combine them. So you don't know which one goes first, so any order is correct. So describe how we got from W to W prime. Well, we went from 3 to 8. We went 5 units right. And we went from 2 to 9. And we went 7 units up. Could we have written 7 units up first and 5 units right second? Yes. There's no one correct way to do this. All right, so describe that translation and be able to say all this vocabulary out loud. I know it's awkward because you're alone, but you should be able to read that. That's line segment AZ to line segment A prime Z prime. So we went 1, 2, 3 units right. And 9 units down. Well, let's see if that checks out. Right, we were at 8. We ended up at -1. Yeah, 8 minus -1, 9. We were at -7. We ended up at -4. Yeah, we went 3 units right, and we could have gone in either order. And notice all the points. You don't have to do any other point. All the points in a translation of an object all move the exact same amount. It never is like this part of it moved this 4 units right and the other part moved 7 units right. Then it would not be congruent. The two objects have to be congruent, the same exact size and shape. Oh, that's what I just said. Okay, so the thing you start with is called the pre-image. And then the thing you end up with is called the image. Just like your reflection is your image, and reflection is actually the next lesson. So we're finding the perimeter of this pre-image, KLMN, not the area, the perimeter. That side is 5. That means the other side is 5. That's a rule of rectangles. The two sides are always the same length. Top and bottom are both the same 2. So we add up all the sides for perimeter. This is not square units. Perimeter is just length around the outside. It takes 14 units to get around that. Translate KLMN, 4 units left and 7 units right. One, 2, 3, 4, right at the edge there. And then 7 units up. 1, 2, 3, 4, 5, 6, 7. Pencil is very helpful here. Remembering it has to be congruent. So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? And you want to put the letters K prime, N prime, You want to neaten it up. N prime, M prime, and L prime. Find the perimeter of K prime, L prime, M prime, and N prime. Well, they're congruent. Congruent objects always have the same perimeter. If they're the same size, they have to, and the same shape, they have to have the same perimeter. They also have to have the same area. All the sides and all the angles have to be the same. That's why we did congruence right before this. All right, so find the area of that triangle. This is 5 square units, right? 1/2 the base times the height, right? 10 square units would be the area of that rectangle. Triangles are always half as big as the same rectangle with the same base and height. Always. So this pre-image is being translated 5 units to the right. So 1, 2, 3, 4, 5. It's actually going to end up across. So this is A prime, B prime, C prime, right? You move each corner 5 units to the right. And the area of that is the same, 5 square units. Because they're congruent, they have to have the same area. All right. You want to pause this video for a second because you're not going to do this quickly. You need to find the perimeter of this. You're going to need Pythagorean theorem for that hypotenuse. Yeah, the hypotenuse there is the square root of 29. All right, so we have square root of 29, we have 2, and we have 5. Well, how do you write all that? Well, you write that as 7 plus the square root of 29. Now, that looks weird to you because it's the first time you've had to do that, but that's a typical thing in high school, right? The square root of 29, right, is a little more than 5, right? Right, square root of 29, we're around 5.3, right? Because the square root of 25 is 5, it's 5.3 or 5.2. And, you know, so it's around 12.3 units. Oh, and this is still units, so you should write units. So 7 plus the square root of 29. Yeah, most right triangles have an irrational side. You'll notice when they're all 3 nice, you keep getting the same combinations. All right, so we have endpoints of this line. So we have a line segment, I apologize, line segment with 5, 2, and 7, and we're finding the new end 1 to the right. So right is, right, adding 1 to the x coordinate. So E prime would be at 6, 2, and F prime would be at 8, negative 3, right? We went from negative 7, 8 to 2, 8. So from negative 7 to positive 2 is adding 9. So we went 9 units to the right. Right? Right, so we translated D to D prime. So it's at negative 7 here. And here is at positive 3, right? This is a relation of x equals negative 7. This is a relation of x equals 3. And we went 10 units to the right. All right. Have a good spring break.